In Notes 14, we're going to introduce and learn to solve one-step and two-step single variable linear equations. First of all, defining an algebraic equation is a statement of equality between two algebraic expressions. So we are going to be seeing an equal sign in these expressions, and that's how we'll know that we're solving something. It is called a linear equation when you have a single variable. And again, there are all the directions, and you can read that if you'd like. I like to show you. All right, well, actually, we'll go through that. Steps and tips for solving linear equations. You want to clear any fractions by multiplying through by the least common denominator. You want to simplify each side as quickly as every single time you do a step. I want to use my words because I think they're a little simpler. Isolate the variable terms on one side of the equation and the constants on the other. That means you get all the x's on one side or whatever you're solving for and all the numbers on the other. Then you use multiplication and division to make the coefficient in front of the variable a 1. That means if you've got a 2 or something out in front of the x, we'll divide it off. And then finally check your answer. We will check our answer on the first 4 examples, and then after that, I will leave that to you. Let's look at our first one. Now, for consistency, I'm going to solve for the x on the left-hand side. I recommend that you do this also until you are a little bit more comfortable with solving. Now, the idea is that we want to get an expression that says x is equal to, right, the answer. And on this first one, it says x plus 7 equals negative 4. To find what x will work, you need to get everything away from the x. This equal sign, though, is very powerful. I can move things to the left and to the right over the equal sign, but anything that gets moved over changes sign this way. I want the x all by itself over here. He's fine there. But this 7 I really wish was on the other side. And he can be. But any number or variable that you move over the equal sign changes sign. Like this. That 7 will become a negative 7 on this side. So now we have the x all by itself, which is what we wanted. And on the other side, 4 minus 7 is negative 3. Now to do a check, after you get an answer and you want to see if it's right or not, you take the original expression or equation, and everywhere you have an x, you put in a parentheses. Then you plug your answer in, and you clean it up. On the left, if I add these two numbers together, negative 3 plus 7 is 4. Notice we got a true statement. When you get a true statement, you got the right answer. So we know negative 3 is correct. Let's do this guy. Now, over here, there was a number being added to the x that we were trying to isolate. Here, we have a negative 3 that is multiplied onto the x. So to unmultiply, you're going to divide it off. But if you do it to one side, you have to do it to the other. On the left-hand side, do you see how the negative 3's cancel each other out? You end up with 1x. That's what we wanted. Then you have to do the same thing to the other side. You want to divide by a negative 3. Well, 15 divided by negative 3 is a negative number. 15 divided by 3 is 5. To check my result, I'm going to build it. Everywhere I have an x, I'm going to use a parentheses and then plug my answer in. Negative 3 times negative 5 on the left become positive 15. Which matches. It's true, so I know I found the correct answer. 1/3 x equals 4. When you have a fraction involved and you want to get rid of it, you want to multiply through by the least common denominator. Let me just say, if it's the only denominator, that is the denominator. But I like to make everything into a fraction. Now, you're going to go through and you're going to multiply every fraction by the least common denominator, which in this case is 3. I multiply 3 onto the first term, and I'm going to multiply 3 onto the second term. Do you see what I did? I found the least common denominator, and I multiplied it onto each piece. Now you can kind of see what's going to happen. The fractions cancel each other out, or the least common denominator will cancel your denominator out there. 3 divided by 3 becomes 1, so I end up with just the 1x all by itself. That's what I wanted to happen. But on the other side, when I multiply these two fractions together, I get 12 over 1, which is 12. Let's do a quick check. I'm going to rewrite it. 1/3 times x equals 4. Now I'm going to plug the 12 in, but I want to make it into a fraction. When I multiply straight across, I'm going to end up with 12 over 3, which is 4, or I can reduce it on the diagonal, whichever one you want to do. 12 divided by 3 is 4. Well, that's 4. 4 equals 4. It checks out, guys. We're doing good. Let's do it with the 2/5 again. I want to multiply through by the least common denominator. If it's the only denominator, it's easy. It's 5. I'm going to multiply that least common denominator onto 2/5 x. Now, notice I wrote the least common denominator as a fraction also. When you're working with fractions, make them all fractions. Now, that means I have to multiply every single piece by the least common denominator. So I'll multiply it onto the 18 as well, and make him a fraction as well. Here, the 5's cancel, so I end up with 2x. On the other side, 5 times 18, and I could, I'm going to go ahead and do the arithmetic for you, and again, you'll have a lot more time on the test. You can do it by yourself. Now, we're going to get 5 times 18 is 90, and now it's similar to number 2. If I have a number that's multiplied onto our x, the very last thing we want to do is divide that number off. But if you do it to one side, you're going to do it to the other side. The 2's cancel, we get x equals, and 90 divided by 2 is 45. Let's run a check one more time. I'm going to build it, but everywhere I have an x, I'm going to plug in my answer, which I got 45. Then I'm going to make it a fraction. Now, I can either multiply straight across and I get 90 divided by 5, but on this one I think I'm going to cross cancel on the diagonal. The 5 and the 45 both have a factor of 5 in common. 5 divided by 5 is 1, and 45 divided by 5 is 9. When I multiply straight across, I get 18 over 1, which is 18. And it checks out, doesn't it? We got it correct. That's how you do it. Now, these are two-steppers. First step is always to isolate the part with the x in it. So, if there's something that's added on, we move it over. When that 1 gets moved over the equal sign, he becomes the opposite sign because he crossed that equal, who's very powerful. That positive 1 looks like a negative 1 on this side. Now we clean it up. I have 6 x's, and on the other side, 10 minus 1 is 9. Now, the only thing that's left is a 6 that's multiplied onto my x. To unmultiply, you divide. I'm going to divide him by 6 to get the 6's to cancel. But if I do it to one side, I'm going to do it to the other. On the left, I get the x all by itself, and on the right, I notice that that fraction is going to reduce a little bit, isn't it? I can divide top and bottom by 3. So I get 9 divided by 3 is 3, 6 divided by 3 is 2, and there's our answer. I'm not going to check any of the rest of them. I'll let you check them on your own. For time's sake, so we can have a nice short video, I'm going to allow you to do that part on your own. Now, I want to get the x's all by themselves on the left, so I'm going to start by moving the 9 over the equal sign. When he gets moved over, though, he changes sign and becomes a negative 9. Now I've got negative 2x equals 15 minus 9, which is 6. All right, all that's left is that negative 2 that's multiplied onto the x. To unmultiply it off, you divide. But if you do it to one side, you're going to do it to the other. On the left, the negative 2's cancel, and I'm left with x equals 6 divided by negative 2 is negative 3. Everything we've learned up to this point comes back into play. It's really wonderful. Let's look at a couple more on this video, and then we'll go on to the next video. I'll stop it and go on to another. Okay, it works the same way with fractions. If I'm trying to get the x all by itself on one side and it's got something added or subtracted onto it, you move it over. That plus 1/2, when he crosses over the equal sign, becomes a minus 1/2. So I have x equals. Now luckily on this one, they already have the same denominator. 3/2 minus 1/2 is 2/2, which is the same thing as 1. And again, you can run a check if you'd like. Same thing on this one. I want to get the x all by itself on the left, but because it's got something added or subtracted on, your first step is to move it over. So we get x equals, and when I move the negative 4/3 over, I get plus 4/3. So I have 1/2 plus 4/3. I'm going to have to get a common denominator. I can, let's see, just do the fractions. I was going to show you how to multiply through by the least common denominator. Let me do that on this one. All right. I can handle it when the fractions have the same denominator, but there's another thing that you can do to make the problem a little bit nicer looking. The common denominator on this one would be 6. And as I mentioned earlier, you can actually multiply every single piece by a denominator to get rid of it. Since 6 is our least common denominator, I'm going to multiply it onto the x. I'm going to multiply it onto that second term. And I'm going to multiply it onto the third term. And watch how cool this is. When I multiply the 6 times the x, I'm still just going to get 6x. But when I multiply the least common denominator onto the terms with fractions in them, I'm going to get a little cross-canceling action there. That's supposed to happen. The 6 and 3 both have a factor of 3 in common. 3 divided by 3 is 1. 6 divided by 3 is 2. When I multiply straight across, 2 times 4 is 8. Same thing here. I can cross-cancel a little bit, or I can just multiply straight across, whichever one you want to do. I notice that they both have a 2 in common, so I'll reduce 2 divided by 2 is 1, and 6 divided by 2 is 3. When I multiply straight across, I get 3 over 1, or 3. Look how much nicer that is. Start by isolating the x's, so I'm going to move the 8 over. Because I moved it over, it changes sign because that equal sign is very powerful. And now I have 6x equals the 3 plus 8, which is 11. To get the x all by itself, and it's got a 6 multiplied onto it, I'm going to divide it by 6. But if I do it to one side, do it to the other. On the left-hand side, the 6's cancel, and on the right, our final answer will be 11 divided by 6.